How are you all? कैसे हो सब? Yeah, tell me in the chat. How are you all? And I shared the links with you in advance so that you can install ID. If you have not done it, no problem. Just move along. It's okay. Yeah. So a laptop or a computer would be better. I don't know about the Android. Okay, you need to check if it is possible Android because I haven't seen. But don't worry, it's okay. Let's get started. Slowly and steadily, we'll get everything. Don't feel overwhelmed because it is just installation. I'll help you. Don't worry. Okay, so let's get started, everyone. Chat will be off. And first of all, welcome to our first robotics class. This is what we were waiting for so long. And trust me, even today, even on the first day, we are going to make some projects and we are going to have lots of fun. All right, just follow along. You don't have to do much here. So let's get started. Let's get started. I'll start with because when we talk about robotics, so robotics is basically if we talk about robotics, what is a robot? A robot is a machine which can make our lives easier. Yes or no? Anything which does work on behalf of human, that is a robot. Is that clear? Now, this robot might include some hardware, like it can have arms, legs, maybe just rotation. Maybe you must have seen that Roomba, what is it called? Roomba, I guess. The thing which moves like a disc, it moves on the floor cleaning it. Yeah. So those are robots. But then there are robots or bots which are totally software based. Yes or no? You must have heard of this phrase, bots. It's a bot. This chat is a bot. Okay. That is also a kind of robot. Now, in this robot, the most important thing is how they decide what to do. Do you agree? For any robot, the most important thing is how it should behave on what situation, how it should react. That is the most important part for any robot. Yes or no? That is the most important part, which means we need to tell it, we need to give it instructions on how to behave. Is that clear? And for that, the starting tool is this. This is the best, I'll tell you, this is the best way of starting robotics. Many people might not agree with me. Most of the people would agree with me, but maybe many people who might not agree with me. But trust me, this is the best platform to learn about not just robotics, but all programming, electronics, everything. Okay, so let's get started, everyone. Okay, so what is an Arduino? Chat is off. Now listen to me very, very carefully. What is an Arduino? Now, if you Google it, this is what you will get. Arduino is an open source platform based on easy to use hardware and software. Like this is like technical garbage which you don't have to worry about. I'll tell you what is an Arduino because this is what you're feeling right now. Ye kya? What is it? What is open source? What is hardware? What is software? Is it? Are you feeling like this? Yes or no? Okay, no problem. This is why I'm here. I'll make it easy for you. No problem. Okay? Dekho kids. In simple words, Arduino is like a tiny brain which we can program. Okay? So Arduino is like a tiny brain that can control different electronic parts like lights, sensors, motors, lots of things. And you can teach it what to do by writing instructions, or you can say code on your computer and then sending those instructions to the Arduino board. So let me tell you what is an Arduino. Arduino is like a brain. It's like a tiny brain, and this tiny brain will work the way we like it. We give it instructions. We will give it instructions. Okay, when somebody walks by this door, you make this sound. Beep, beep. You must have seen in shopping malls, in airports, there is a machine. When you pass through it, it makes a sound. Yes or no? Yeah? Yes or no? So that is done by a tiny brain. There is a microcontroller even there. When somebody passes, you make this sound. So you are giving instruction to it. Is that clear? So this is just a solid hardware. Unless we tell it like what to do, it won't do anything. We have to tell it, okay, this is what you're supposed to do when this happens. This is what you're supposed to do after that. This is what you're supposed to do after that. Is that clear? So we need to give it instructions. And this instructions is what we are calling code, the program code. All right. In the language of Arduino, we call it a sketch. So what is a sketch or a code? It is a set of instructions we are going to give it. And that is what we are doing. We were installing IDE. We are going to give instruction through ID. All right. Okay, very simple. So far, so good. Now, what can you do with Arduino? Like, why we are learning about Arduino? So, you can make a self-controlled car using Arduino. Okay, you can make a line follower robot, obstacle avoiding robot. There are lots of different types of robots. You can make a robot which moves along a wall. Okay, so you can have a self-driving system using Arduino. Pretty cool, isn't it? Then we also have, I mean, this is pretty advanced. So you take a sensor which can measure your SpO2 level, your oxygen level, okay? And we can show it on a tiny screen using Arduino. Isn't it cool? Okay. We can we can do all sorts of things. You can make animations using Arduino. So here is we have tiny Arduino. Here is a little screen, and you are getting those animations. These animations are programmed by people. All right, it is not just random video. It is programmed. The instructions were given. These pixels must lit up, and then this whole thing should rotate. How it rotates? Keep them off, keep them on, keep them off, keep them on, like that. So all of these are instructions. All right. You can create these fun things like this thing is moving. Okay, the scientist is moving using Arduino. There is a motor, a stepper motor. A motor is there, and there is a scientist, and we can control it. Okay, lots of cool things. You can. I have deliberately taken this photo because you can hack into your switchboards. So we all have switchboards in our house. We have lights, we have fans. है ना? So you can make this very simple system where you can control the existing system. You can control the existing system from the comfort of your phone. Very cool. In fact, let me play some videos. All right. This is controlled by Arduino. We have a tiny radar. We have a missile system. Very cool. Very cool. So they are a bit advanced, but yes, these are the possibilities of using Arduino. Do you like these robots, kids? Tell me, do you like these robots? Yeah, pretty cool, no? Pretty cool. All right, great, very good. Okay, let me play some more videos. Let me play one more. So you can even make this kind of a system. Basically, उसे क्या बोलते हैं? What is this? Whatever. ठीक है, this thing which stops the car. I'm not getting the word. All right. So that can be programmed. You can make that as well. So lots of things using simple components like a servo motor, an ultrasonic sensor. You can create all of these things. So this is the world of Arduino. Now let me first of all give you some coins. Yeah, let me give you coins. By the way, how many of you already know some things about Arduino? How many of you know? You know? Okay. Some of you already know. No problem. So there are certain people, but in today's class, I'm going to assume that no one knows about Arduino. So I'm going to start from very basics. All right. I'm going to start very slowly. I'll take you from a very, what to say, beginner level. Okay. I'm assuming you all are beginner. You do not know anything about Arduino. So I'm going to start from the very basic. All right. Chalo, let's get started, everyone. Let's get started. Chat is off. So, how any electronic system works, or how do we make use of Arduino? Okay, so let me explain. To understand this whole ecosystem, to understand this whole process, I will take an analogy. Imagine you want to make an alarm clock. You want to make an alarm clock. Okay, how would you make an alarm clock? What are the things needed? So, in order to make an alarm clock, first of all, you need a clock. But suppose if you want to produce sound at a particular time, first of all, you need that time measuring device, basically a clock. Make sense, yes or no? How are we going to make an alarm clock? First of all, we need a clock. Okay. Then what? What do we need? You tell me, kids, you tell me in the chat. What do we need next? So we have a clock. In order to make an alarm clock, what do we need? Sound. Yes, very good. We need a buzzer. We need a sound producing component. We need some mechanism through which we can actually produce sound. A speaker, a buzzer. Is that clear? Make sense? Very good. And what do we need next? So I have a clock. I have a sound producing device. So how a human alarm clock would work? Imagine human alarm clock. There is a person. The person is looking at a clock, and this person has one bell. So when the person sees, oh, it's 8 a.m., ring the bell. So do you need somebody who can recognize what time is it, and now it's the time to produce sound? Do you agree? What do we need? We need something. We need someone who can recognize what time is it, and when that time comes, it has to produce its sound. Basically, we need something like a brain. Yeah. So what are the things needed? Chat is off. What are the things needed? The things needed are first of all we need a clock, something which is showing you time. You need a sound producing device, and you need something like a brain which can process this information. Agreed? Is that clear? Is that clear? Whenever we make such systems, okay, based on this situation, this should happen. We need something which can process information. All right. And that is where we have like brain. Now, what is the brain in these alarm clocks, in these digital clocks, in mobile phones, in lots of electronic components? What is this brain? This brain, because clock can be anything. We can have digital clock, sound producing, we have speaker. But which component will do the brain's work? We have these things. Anybody? These are like processors. Okay, they process information. But this is a big one. This is like inside the computer. For our purpose, we are going to use a smaller brain. Okay, a microcontroller. So this is a microcontroller. You can say a tiny brain. Is that clear to everyone? Very good. Shabash, that is off. Very good. So what is a microcontroller? Microcontroller is like a tiny computer, or you can say it is analogous to brain. Yeah, it receives information, and based on that information, it does certain actions. Just like just like an alarm person would do. So they are seeing things from their eyes. They are sensing using their sensory organ, which is eyes. They see that, they get some information, they process it, and they do some action. In the similar way, this is like a brain. So all these pins, they can receive information, and they can give information. Are you getting me? They can receive some signal, and they can give some signal as well. That is what they do, just like a human mind would do. From our eyes, from our senses, touch, ears, okay, nose, we get all this information, and based on that information, we do certain actions. Make sense? Exactly in the similar way, a microcontroller does that. Okay. So, first question of today's class: what is analogous to a brain in electronics? What is analogous? Basically, similar to brain in electronics. Microcontroller, motor, battery, speaker. Very easy question. Come on, everyone, hurry up. Easy question. Yes. Very good. Hurry up. Kids, the good part is coming. Don't worry. Even if you know Arduino, even if you have some experience, even you are going to have some fun. Don't worry. Because the main thing I'm going to teach you is not just hardware, but it is the principles of programming. And this is where you're going to have fun. Come on, everyone. Shabash, Hariya, very good. Please do this question. What is analogous to a brain in electronics? Okay, last 10 seconds. Shabash, very good. Last 10 seconds, everyone. Hurry up. Very easy question. Just testing you, like if you're listening to me or not. Microcontroller. So microcontroller is like a tiny processor, all right? Uh, Analogous. Okay, similar to a processor. It does computing, it processes the information and does action. Yeah. And this is what we have to program. This is what we have to give instructions to. So a microcontroller is like a tiny computer. But will it work on its own? I mean, how do we tell it like this is what you're supposed to do, my tiny brain? Are you getting me? When this time comes, you have to give current to the buzzer, you have to give current to a speaker and produce sound. I mean, we want to give this information to this microcontroller. When this time comes, when it is 8 a.m., you have to give current to the speaker and speaker should make some sound. The buzzer should make some sound. Make sense? Yeah. By the way, how is this GIF? I'm very proud of making this. Nice, no? Okay, great. आगे बढ़ते हैं. Chat is off. Very good. So kids, yes, we have to tell it. We have to tell it like how you're going to work. Now, in earlier days, programming this microchip or microcontroller was very, very difficult. Okay. In earlier days, before Arduino came into the market, we had to make circuits on our own. Then we need to attach one hardware which is called programmer, and then using very old ways of and difficult ways of programming, we had to program it. But Arduino is so famous because it made it so simple that anyone can just plug and play. This is why Arduino is so famous. Arduino made it very, very simple to program that microcontroller. Okay, I'll show you how easy it is to give some instructions to it. Okay, so Arduino makes it easier to program a microcontroller. See, I was talking about this microchip. I hope you can see in your Arduino. Those of you who have Arduino, they can see. Like here it is. Here it is. This is the microcontroller. Okay. So the circuit is already made. You don't have to do anything. You just use your USB cable, plug and play. Okay. That is why Arduino is so famous. So if you look at the Arduino, it has these things. We don't have to get into every detail, but I'll just is your microcontroller, and here are the pins. I hope you can recognize everyone. Can you recognize? We have the microcontroller here. There is a microcontroller, and these are the pins. This is where the jumper wires will get into. Okay, let me show you. Let me show you, everyone. Yeah. So I hope you can see. So here is the Arduino board. Here, this is what we are calling microcontroller, this thing. Okay. It can come out, but don't do that. And then I hope you can see these holes. You can put these jumper wires like this. You can insert. So kids, you tell me in the chat, are you able to do this? Everyone, this is your first task. Take Arduino and in any pin, you insert your jumper wire, jumper cable. Okay, very good. So very simple. Yes, very simple, but I want you to do it. All right. Chalo, chat is off. Chat is off. All right, kids. Okay. So it is very easy to program. And there are two things, like I said, where I want you to focus on. The first thing is this chip. Then these are the pins. I'll explain the pins. Don't worry. I'll explain the pins and everything, what they do, how you're going to use it. Don't feel burdened or don't feel overwhelmed. Okay. मैं सब समझाऊंगा आराम आराम से. Easy. Okay. And this is where we are going to put our cable. Now, can you please tell me if you're able to insert this cable like this? Are you able to do this? Tell me in the chat. Come on, everyone. Yes, easy. And you can connect the other part to the computer. Okay, very good. Shabash. All right. Chat is off. Very good. Okay, I will explain the functions of the pins, how to use them, everything. I'll tell everything, okay, slowly and steadily. All right, kids. So basically, these things are called digital pins. And I'll tell you very, very simply like what they are. Do you remember cells and batteries? In cells and batteries, there are voltages. Or you can say, first of all, on a cell, we have two terminals. And cells have voltages. Do you remember, yes or no? Do you remember? Correct? I hope you remember. Okay, very good. All right. Now, one terminal is going to be ground always. Suppose I want to switch on this LED. Suppose, kids, now listen to me. I want to switch on this LED. Now, I hope you know this. There are two terminals on this LED. So I need to supply power on these two terminals using the two terminals of the cell. Yes or no? Yes or no? If I want to switch this on, there are two terminals. I need to provide power using these two terminals. All right. I have to attach the two terminals of the cell here. Those two terminals from the cell will be provided by these pins. So first of all, we have ground. This is going to be common. Okay, this is going to be common. And then for the other, we have these many things. I can directly take 5 volt, but I can also use this. Again, as for now, only this information. I'll tell you the next piece of information later. So we have 14 digital input output pins. We have 6 analog pins. We have 6 analog output pins. But again, just for a moment, you can ignore all of this. The next important part is Arduino IDE. IDE is basically integrated development environment. Simply put, it is a software where we are going to do the programming. Let me show you. All right, this is IDE. So basically, I can write things here. I can write things. I enter. I write something. So how many of you have installed Arduino? Yeah. So this is where we are going to write the program. You have installed. Very good. Kids, you can take help from your parents. You can take help from your parents. Okay. Download and install Arduino IDE. Okay. Chat is off. All right, kids. Okay. So now that you have installed it, many of you have done that. Those of you have access to a laptop and all the things we need. We are going to move the next. So basically, this is where we are going to write our sketches. This is called a sketch. What is a sketch? All these things are instructions. These things are instructions. Okay, they're nothing but instructions. So we write the instructions, all these. And again, please do not get confused about what is written. I'll explain everything. I'll explain. As of now, just follow my cursor. I hope you can see these lines. So these are instructions. These are instructions. All right. And this is what we have to write. Okay. Simple. Don't worry. All right. So in the IDE, in Arduino IDE, we write codes, we write instructions, and we upload these instructions using the USB cable to our Arduino board, and the Arduino board is going to work based on that instruction. All right. I hope it is clear. So, like I said, Arduino program in Arduino language is known as a sketch. Just like with drawing, we make a sketch. In the similar way, programmers, their art is the line of code they write. That is why it is known as a sketch. So sketch is the name given to Arduino code. Okay, it is the Arduino code. All right, that is a sketch. All right, kids. So let's do some questions. Can a microcontroller do everything on its own? So basically, the question is asking, can a microcontroller will understand if I speak to it, okay, do work like this. You are supposed to switch on the lights when the sun goes down. All right, understood. Will it work like this? Will it work like this or option B? It needs to be programmed. What is the answer? Come on. Very simple question once again. It needs to be programmed. We have to give information to it, instructions to it. Okay, come on, everyone. Shabash. Very good. Shabash, hurry up, everyone. So, simple question. Can a microcontroller understand our language if I speak to it? All right. And it will work. Maybe in future we'll get those kinds of things, but not yet. Yeah, that's it. It's not Alexa. Alexa, play this music. It's not Alexa. It's a microcontroller. You have to give instructions to it. By the way, even Alexa works on the same thing. It has a controller. It has one processor inside it. And that processor works according to the instructions given by those software developers. Okay, when a human says, Alexa, play this particular song, it will play that song. Okay. So the thing is, a microcontroller has to be programmed by us. We have to write programs for it. Make sense? Very simple. Okay, next question. Where do we program Arduino? I mean, what is the name of that software where we program Arduino? Is it Arduino IDE or is it a media player? Come on, do it. Very easy question. Where do we program Arduino, everyone? Come on, hurry up. Come on, everyone, hurry up. Okay, last 10 seconds in 5, 4, 3, 2, 1. Last 10 seconds, kids. Last 10 seconds, everyone, hurry up. Okay, it is Arduino IDE. Very good, kids. Very good, Shabash. Very nice. All right, so the answer is it is Arduino IDE. All right, next question. What is an Arduino sketch? What do we mean by a sketch? What is a sketch? A computer program which Arduino uses to run on a drawing made with crayons. What is an Arduino sketch? Let's go. Very good. Very good. Shabash. Come on, everyone. Shabash, hurry up. Okay, last 10 seconds. Shabash, last 10 seconds, everyone. All right, so Arduino sketch is, we call that program. Okay, when we write the code, we are basically saying, we say, ki, oh, we are making a sketch. Are you getting me? So it's just a terminology, it's a word which we use. So it is the name of the Arduino program. Is that clear to everyone? Just like an artist draws and call it a sketch, they're making their art. We also are going to make art, but that is like art on computer. Okay, it's an art. It's an art. Programming is an art. So we are going to make our sketches here. All right. Chalo. Chat is off. Very good. Now, kids, Arduino board, this hardware, this is called hardware. Hardware is something which you can feel, you can touch. This is hardware. Understood what is in hardware? And software is which lives inside the computer. Okay. So hardware, Arduino board and all these things like LEDs, wires, okay, breadboard, these things and all the sensors we have bought today, they are hardware. Something which you can sense, touch, feel. And software is, for example, we're writing the code, that instruction. All right. That is what a software is. Make sense? Is that clear? A software is information, basically. Information you cannot touch but makes sense. Information can be seen when it is written, but that lives inside a memory. Make sense? Is that clear? So Arduino board plus IDE, totally awesome. That is what we are going to learn. All right. Chalo. Chat is off. Very good. Okay, kids. So we are going to write our first Arduino code, and I hope you have installed everything. So this is the programming cycle. Basically, I have explained it already, and I'll explain it using these words, text. So the step one is plug your board into USB port of a computer. So whenever we are writing or we want to make something, first of all, we have to plug your board into the USB port of your computer. Why are we doing that? Why this thing needs to be plugged into a computer? Why? Anyone? Why? Yes, for programming. Very good. Why we have to connect it to the computer? Why are we doing that? So that we can send instructions through the wire to it. Is that clear? So that whatever code we are writing, it needs to be uploaded. So it is going to be uploaded using this wire. Okay, make sense? Very good. To receive information. Okay, the second step is going to write a sketch that will bring the board to life. So a board, when there is no code, like I said, it will be lifeless. It will not do anything. It does not know what to do. So when you write a sketch, when you give instructions, this is when the board will start functioning based on your instructions. Then we are going to upload this sketch to the board using the USB connection. Okay. And finally, the board executes, or you can say performs, the sketch that you have written. Basically, the board is going to work based on the instructions you have given. That is the programming cycle. All right. Is it clear to all of you? All right, kids. Okay. Clear? Chalo. Now we are going to make our first program. So kids, what you have to do, I'll show you. Okay. So the first thing you are going to do is, yeah. So we have the Arduino board. There is this cable. This cable is connected to our USB. Okay, because I have a Mac, I need to use this connector. But you can, if you have the USB port, you can directly connect it. I have to use this connector because there is no USB port. Okay, but I guess you have a USB port on your laptop, so you can directly put this wire, the other end is here, the other end is here. You can put it into the USB port. So first of all, tell me, how many of you, yeah, how many of you have done that? How many of you have plugged it? Have you plugged it in? Okay, it must be blinking. It must be blinking. Yeah, done. It must be blinking. All right, chat is off. Chat is off. Okay, so kids, yeah, wait a minute. Okay, so it must be blinking something like this. So when you plugged it in, it must be blinking like this. Yes or no? Tell me. Yes or no? It must be blinking like this. Yes. All right. Great. All right. So far so good. So far so good. All right, kids. Now we are going to make our first. program. Okay, we are going to make our first program. All right, kids. Yeah. How? After connecting it, you will go to file. Okay, so let me show you. You will go to file and then go to examples. Everyone, please do it and tell me if you can do this. Go to file. I hope you can see. So you go to file, go to examples. Can't see. Go to file and go to examples. Anyone? Can you do this? Yeah. It is. Oh, sorry. I'm really sorry. Okay, okay. Yeah, I forgot that. Ha. Now you can see, na. Now you can see. So you go to file and go to examples. Yes. When you go to examples, go to basics and go to Blink. Can you see? First, you go to file, click on examples, click on basics, and click on Blink. Can you do this? Yes or no? Tell me. All right. Okay. So now, kids, when you go to Blink, when you go to Blink, double click on it, and you will get a new window. Chat is off. Okay. Now you can see the code. It will be written something like this. It will be written something like this. Void setup, pin mode, like this. Can you see all of this? Everyone tell me yes or no. Can you see void setup, pin mode, LED built in? Yes. All right, great. All right, great. Okay. Now, kids, what we are going to do, here you can see upload button. Can you see the upload button? If you go to upload, you click on this. When you upload, you will get the confirmation here. Okay, done uploading. Please give me the information, confirmation if you have done that, yes or no. Click on upload. It must be uploaded to the board. Yes. All right, great. Very good. Okay, it is uploaded. Now, if you see something like void loop, digital write LED built-in high, delay 1000, digital write LED built-in low, delay 1000. Okay, let me show you what is happening to the board and you try to make sense of it. See what is happening. Look at this LED, the orange one. Isn't it switching on for 1 second and off for 1 second? Isn't it on for 1 second, off for 1 second? Yes or no? Yes. Look at the orange LED. Okay. And look at the code here. Look at the code. All right. 1000 high, 1000 low. Can you make some sense of it? Like what is this doing? You must make some sense. What is it doing? Anyone? See, it will make more sense if I change the number. All right. So what we are going to do, you copy this thing till void, you copy. Okay. Because we are going to do some changes to it. You copy this and go to file again and make a new sketch. Go to file again and make a new sketch. Okay. And then we'll paste it. This is how we're going to start. Very slow. Very easy. Okay. I'm going to select it, drag it, and then I'll press Control V or simply right click and paste. Okay. Done or not? Tell me, kids. Is it done or not? I have made a new file. I've made a new file and I've copied and pasted. Done? All right. Very good. Chat is off. Now, kids, see what I'm going to do. First of all, instead of LED built in, I am going to write 13. Okay. So let me attach it here. All right. Instead of LED built in, I'll write 13. Wherever LED built in is written, I'll write 13. I'll explain in a moment why. 13 and 13. Okay. So instead of LED built in, I will write 13. Forget everything. You can ignore everything. Okay. And I'll again, first of all, you have to save it. So Control S or Command S, it will save. You save it as it is. No need to change anything. This is our first program. So we'll keep it simple. Okay. Now I have saved it. After saving, you can upload. Let me upload. You just observe. You don't have to do right now. You just observe. I have uploaded it. Okay, uploaded. Now let me show you the same code, and it is working the same way. Basically, this LED is connected to pin 13. Can you see pin 13? This LED is connected to pin 13. So you write LED built in or you write 13, it's the same thing because 13 is connected to there. Is this one clear? So instead of built in, you can also write 13. So 13 is the pin number. Now I hope you have understood what is built in. This is the LED in the board. So that's why it is a built-in LED. It is a built-in LED and it is connected to 13. Okay. Now comes the fun part. See kids, I am going to write instead of 1000, I am going to write 2000 or maybe 5000. I'm going to write 5000. I hope you can see. I will write 5000 and upload. Now, can somebody guess what it will do? Can somebody guess what it will do? Anyone? Yes. So high means on. It will be on for 5000 something. We don't know what is this 5000, but high means on for 5000. And look at the board, what it is doing. And it will make sense. You time the, you count the time. Isn't it on for 5 seconds? Isn't it on for 5 seconds and off for 1 second? It is on for 5 seconds and off for 1 second. Yes? Okay. Chat is off. So kids, what this code is doing, this code is telling which pin is going to be on for how much time. And this time is in millisecond. Basically, you have to divide this by 1000 and you will get the time. So 5000 divided by 5, what do we get? Everyone, 5000 divided by 5, what do we get? 5 seconds. So we are saying that you keep pin 13 high for 5 seconds. You keep pin 13 low for 1 second. Is that clear? Is that clear to everyone? Yes or no? Okay. Yes. This is very easy. What would this do? You tell me. If I keep it for 200 or maybe 500 and this one is also 500. Can somebody tell me what this would do? Tell me kids what this would do. Everyone, on for 0.5 and off for 0.5, yes or no? On for 0.5, off for 0.5. Let me upload it. So it will blink faster. Yes or no? It will blink faster. All right, let me show you. 0.5 second. 0.5 second. So if I keep 500, 500 divided by 1000, 0.5. So this is the first lesson. Basically, what we are doing, we are manipulating the code by a tiny bit, which affects on how this LED functions. If it is not clear to you, what I'm going to do, I'm going to insert a bigger LED. I'll explain this as well in the next class. But to make things easier, just a minute. Okay. Can you see? So it is blinking faster. It is blinking faster. 0.5 seconds on, 0.5 seconds off. All right. Any change you want to do, you tell me. I'm not going to change anything, just the time. What time we should do? 20, 1 million. It will be on 1 million. Okay, let's do it 300. Let's do it 300. Okay, 300. Now let me upload it. Now let me upload it. And guess what? What will happen? Now it will switch on and off very, very quickly, like zero point 0.3 seconds on, zero point 0.3 seconds off. Is that clear? Okay. So this is our first program. This is the blinking program. All right. And it is a great way to start learning Arduino. Is that clear? Okay. All right, kids.